Hello students, welcome to another video. Today we will be solving Pure Maths Paper 1 from May-Jun 2017, Variant 12. Now let's look into the first question. Question number 1, it says, find the coefficient of x in the expansion of 2x minus 1 by x within brackets to the power 5. So this will be 5cr 2x to the power 5 minus r minus 1 over x to the power r. Now let's isolate the x terms. So that will be x to the power 5 minus r and times x to the power minus r, because r is getting this power is getting multiplied with all the powers inside for the numerator and the denominator. So when you bring x to the numerator, it will be x to the power minus r. Now, since the question says that we need to find the coefficient of x, which is the same as finding the coefficient of x to the power 1. So we isolated the x terms, and this should be equivalent to x to the power 1. So when we are multiplying, the power gets added. So 5 minus r plus minus r will be 5 minus r minus r equals to x to the power 1. Or we can say x to the power 5 minus 2r equals to x to the power 1. So with the help of equality rule, now we can say 5 minus 2r is equal to 1. Therefore, 2r is equals to 4. So r will be 2. Now we can use this value to find the coefficient of x. So it will be 5c2, 2x to the power 5 minus 2 is 3, minus 1 over x to the power 2. 5c2 is 10, 2x cube will be 8x cube, times 1 over x square. That will give us 80x. So the coefficient of x is 80. In part 2, it says, hence find the coefficient of x in the expansion of 1 plus 3x whole square with the factor that we were dealing with earlier. So now what we need to do, we need to find the coefficient of x to the power minus 1 for this, because when 3x square will get multiplied with this expansion, in order to find the coefficient of x, if we have a coefficient of x to the power minus 1, by multiplying 3x square with the coefficient of x to the power minus 1, we will get x as the coefficient of x. So again, we need to isolate the x terms from this expansion. So it will be x to the power 5 minus r times x to the power minus r, which should be equal to x to the power minus 1. So since it's getting multiplied, the powers will be added. So 5 minus r plus minus r is minus r equals to x to the power minus 1. So x to the power 5 minus 2r is equals to x to the power minus 1. So 5 minus 2r is equals to minus 1. Therefore, 2r will be equals to 6, hence r is equals to 3. So when r is equals to 3, 5c3 times 2x whole square, because 5 minus 3 is 2, and minus 1 by x to the power 3. 5c3 is 10 and 2x square is 4x square, times minus 1 over x cube. So this will be minus 40 over x. So previously we found the coefficient of x for this expansion was 80x. So 80x times 1 will give you 80x. Also, when you're multiplying 3x square with this minus 40 over x, you will also get minus 120 over x. That is the reason why we needed to find the coefficient of x to the power minus 1. That way, when you simplify this, when you are multiplying 3x square with negative 40 over x, x will cancel out, x and the square will cancel out, and you will be only left with minus 120x. So adding these two will give us 80x minus 120x, which is equals to minus 40x. So the coefficient of x is 40 when you are multiplying this expansion with this. Question number 2, it says The point A has a coordinate -2, 6. The equation of the perpendicular bisector of the line AB is 2y equals to 3x plus 5. We need to find the equation of AB. So let's first convert this equation in the form of y equals to mx plus c. So we can see that will become y equals to 3 over 2x plus 5 over 2. So the gradient of AB, this is the equation of the perpendicular bisector. So the gradient of the perpendicular bisector is 3 over 2. That means the gradient of AB should be -1 over the gradient of the perpendicular bisector, and that will give you the negative reciprocal, which is -2 over 3. Since we know the gradient now and we know a coordinate, then of course we can manage to find the equation of the line AB. So that will be y minus 6 equals to -2 over 3 within brackets x minus -2, which is x plus 2. So cross multiplying 3 with this y minus 6 will give us 3y minus 18 equals -2x, -2, and +2 will give us -4. So 3y plus 2x is equals to 14. And that is the equation of the line AB. In part 2, it says find the coordinates of B. So the equation of the line AB was 3y plus 2x equals to 14. Now let's make y the subject of the equation. So that will become y equals to 1/3 of 14 minus 2x. Let's consider that to be equation 1. And also we have 2y equals to 3x plus 5. Now again let's make y the subject, and that will become y is equals to half of 3x plus 5. Now let's find the point of intersection of these two lines. So using equation 1 and 2, when we equate these two equations, we get 1/3 of 14 minus 2x is equals to half of 3x plus 5. Cross multiplying, we get 28 minus 4x is equals to 9x plus 15. That means 13x is equals to 13. Therefore, x should be 1. So when x is equals to 1, we can substitute this value in any of these equations. But it's easier to use the equation 2. So y is equals to half of 3x. So 3 times 1 is 3 plus 5. And that will give us 4. So basically, the point of intersection is the midpoint for the line AB. And that is 1 and 4. The midpoint is 1 and 4. So we are required to find the coordinates of B. So x coordinate of B should be x1 plus x2 divided by 2. So x1 plus x2, where x2 is -2. If we look into the coordinate of A, that is -2. So x1 plus x2 is -2. So x minus 2 divided by 2 should give us the midpoint, the x coordinate of the midpoint, which is 1. And the y coordinate of B should be y plus 6. 6 is the y coordinate of the point A. So y plus 6 over 2 should give us the y coordinate of the midpoint, which is 4. So x is equals to 4 and y is equals to 2. And that will be the coordinate for B. Question number 3. It says prove the identity 1 over cos theta minus tan theta whole square is equivalent to 1 minus sin theta by 1 plus sin theta. Considering the left hand side of the equation, 1 minus cos theta minus sin theta by cos theta whole square can be written as, so this is a minus b whole square. So a square will be 1 by cos square theta minus 2ab. So 2 sin theta by cos theta and times 1 by cos theta will give us 2 sin theta by cos square theta plus sin square theta by cos square theta. So if we take cos square theta as the LCM, then we will be left with 1 minus 2 sin theta plus sin square theta in the numerator. If you look closely into this equation, this is 1 minus sine theta whole square, this whole equation in the numerator, because if you expand it, you can see that it is 1 square minus 2 into 1 into sine theta plus sine square theta. So that means this equation can be written as 1 minus sine theta whole square. So we have 1 minus sine theta whole square in the numerator, and cos square theta can be written as 1 minus sine square theta. We can also say that 1 minus sine square theta can be written as 1 square minus sine square theta. And with the help of this, we can say, with the formula that we know, which is a square minus b square, that gives us a plus b, a minus b. So 1 square minus sine square theta can be written as 1 plus sine theta and 1 minus sine theta. Now we can cancel 1 minus sine theta and the square of the 1 minus sine theta from the numerator, and then we will be left with 1 minus sine theta over 1 plus sine theta. In part 2, it says, hence solve the equation 1 minus cos theta minus tan theta whole square equals to half. We know that this can be written as 1 minus sine theta by 1 plus sine theta equals to half. So if we cross multiply, we will get 2 minus 2 sine theta equals 1 plus sine theta. Or we can write it as minus 3 sine theta equals to minus 1. If we multiply both sides by negative 1, we get 3 sine theta equals to positive 1. So sine theta equals to 1/3. Now let's find the basic angle. So the basic angle alpha is equals to sine inverse of 1/3. And we know that sine, the positive sign, belongs to the first quadrant and the second quadrant. The value of alpha comes down to 19.471. And let's check the limits. The limit is between 0 to 360. So we can definitely take both of these quadrants. So it will be the basic angle will be the actual angle. Also, 180 minus the basic angle will be our second value. Question number 4. It says the diagram shows a circle with radius r centimeter and center O. Points A and B lie on the circle, and ABCD is a rectangle. Angle AOB is 2 theta and AD is r. We need to express the perimeter of the shaded region in terms of r and theta. So let's first find the arc length AB. AB is equals to, the formula for the arc length is r theta. And in this question, the radius is also r and theta is 2 theta. So it will be r times 2 theta. So that gives us 2r theta. The chord length AB, the chord length, so let's say there is a line segment between A and B. So the chord length AB square is equals to, with the help of the cosine formula, we can find the length of AB. The reason why we are trying to find the length of AB, because ABCD is a rectangle. So the length of AB should be equal to DC, and that helps us to find the value of the perimeter of the shaded region. So let's find out the value of AB. So with the help of cosine rule, AB square is equals to r square plus r square minus 2 into r times cos 2 theta. So that will be 2r square minus 2r square cos 2 theta. If I take 2r square common, then I will be having 1 minus cos 2 theta within brackets. Again, if I keep 2r square outside, and I can write cos 2 theta as 1 minus 2 sine square theta. The reason I'm doing that, because I want to get rid of this 1. So when I open the brackets, after manipulating cos 2 theta, I'm getting 1 minus 2 sine square theta. So after opening the brackets, it becomes 1 minus 1 plus 2 sine square theta. Minus and minus will give us plus. So 1 minus 1 cancels out, and then we have 2r square getting multiplied with 2 sine square theta. So this becomes 4r square sine square theta. That is the value of AB square. So AB must be square root of 4r square sine square theta. So since all these are squares, 4 is a square number. So if we square root the whole thing, it becomes 2r sine theta. Now, chord length of AB is equals to DC, which I have stated earlier, which is equals to 2r sine theta. So the required perimeter is, let's have a look at the diagram again. So it will be this length, this length, this length, and the arc length, which is 2r theta, that is the arc length, plus r, which is on the left hand side, plus 2r sine theta, which is the length of DC, and the r on the right hand side. So together, if you simplify it further, it will become 2r theta plus 2r plus 2r sine theta. And this is how we have just expressed the perimeter of the shaded region in terms of r and theta. In part 2, it says, in the case of where r is equals to 5, theta is equals to pi over 6. Find the area of the shaded region. Area of the minor segment AB. So in order to find the area of the shaded region, what we can do, let's look into the diagram again. So in order to find the area of the shaded region, we can take away the area of the minor segment AB from the area of the rectangle, and we will be left with the area of the shaded region. So area of the minor segment is half r square theta minus sine theta, where r is r and theta is 2 theta minus sine 2 theta. Now they have stated that in the case where r is equals to 5, that means we can substitute the value of r as 5. So half into 5 square times theta is now pi by 6. So 2 times pi by 6 minus 2 times pi by 6. That will give us 2 pi by 6 is basically pi by 3, and we know that sine pi by 3 is root 3 by 2. So the value that we get eventually is 25 over 2 within brackets pi over 3 minus root 3 over 2. Now area of the rectangle. Area of the rectangle is length into breadth. So it will be r into 2r sine theta. That was the length of DC, if you can recall. Then since r is now 5 and theta is pi by 6, so it will be 5 times 2 times 5 times sine pi by 6. And sine pi by 6 is half. And 5 times 2 times 5 is 50. So the area of the rectangle ABCD is 25. Now the area of the shaded region should be area of the rectangle minus area of the minor segment, which is 22.7 square units. Question number 5, it says a curve has equation y equals to 3 plus 12 over 2 minus x. Find the equation of the tangent to the curve at the point where the curve crosses the x-axis. So we can write the equation of the curve as y equals to 3 plus 12 times 2 minus x to the power minus 1. That will help us to differentiate it easily. So dy by dx will be 0 minus 1 times 12 is minus 12. 2 minus x to the power minus 1 is minus 2. So that is the outside differentiation. Then the inside differentiation should be minus 1. So we can write it as 12 over 2 minus x whole square. This negative 1 and negative will make it a positive value. So since the equation of the tangent to the curve at the point where the curve crosses the x-axis, so we can say that at x-axis y is equals to 0. So substituting y equals to 0 in the equation of the curve, we get 0 is equals to 3 plus 12 over 2 minus x. So if we cross multiply, before cross multiplying 2 minus x with 0, we need to multiply 2 minus x with 3 because there is no 2 minus x in the denominator. So 2 minus x times 0 is 0, and then 3 times 2 minus x plus 12. So that will give us 0 is equals to 3 to the 6 minus 3x plus 12. So 3x is equals to 18. Therefore x is equals to 6. So this is the point where it cuts the y-axis. it cuts the x-axis. So coordinate is 6 and 0. When x is equals to 3, let's find the gradient. So we know the equation of the gradient, which is 12 over 2 minus x squared, 2 minus x whole square. So substituting x equals to 3, this will be x equals to 6, not x equals to 3. So when x equals to 6, dy by dx is equals to 12 over 2 minus 6 whole square, which is equals to 12 over 16. Simplifying it further, we get 3 over 4. So equation of the tangent, we can use the formula y minus y1 equals to mx minus x1. So over here, our y coordinate is 0 and x coordinate is 6. And the gradient we found is 3 over 4. So y minus 0 equals to 3 over 4 times x minus 6. So 4y is equals to 3x minus 18. And that is the equation of the tangent to the curve. In part 2, it says a point moves along the curve in such a way that the x coordinate is increasing at a constant rate of 0.04 units per second. Find the rate of change of y coordinate when x equals to 4. So it's better that we extract the data from the question first. So since x coordinate is increasing at a constant rate of 0.04, that means dx by dt is equals to 0.04. And it's also given that x equals to 4. What we need to find is the rate of change of y coordinate. That means we are required to find dy by dt. So let's first solve dy by dx, which we already know. Dy by dx is equals to 12 by 2 minus x squared. So in order to find dy by dt, we can take the help from chain rule, which is if we form an equation, dy by dt can also be written as dy by dx times dx by dt. So dy by dx is 12 over 2 minus x whole square times 0.04. And this can be simplified further as 0.48 over 2 minus x whole square. So when x equals to 4, dy by dt is 0.48 over 2 minus 4 whole square. That gives us 0.48 over 4. That means dy by dt will be 0.12. Question number 6. The diagram shows the straight line x plus y equals to 5 intersecting the curve y equals to 4 over x at the points a 1, 4 and b 4, 1. Find, showing all the necessary working, the volume obtained when the shaded region is rotated through 360 degree about the x-axis. So for the curve y equals to 4 over x, since we need to find the volume, let's find y square. So y square should be 16 over x square. For the line x plus y equals to 5, so y will be 5 minus x. Therefore y square should be 5 minus x whole square. Or this can be written as, with the help of a minus b whole square formula, this will be 25 minus 10x plus x square. So the required volume is pi with the limits 4 and 1. If we check the diagram, we can see that these are the limits. The x coordinate of b is 4, so this is the limit, and the other x coordinate is 1. So we are taking these two limits in order to find the volume when it is rotated 360 degree about the x-axis. So pi with the upper limit 4 and lower limit 1, that is the equation of the, it was the equation of the line, and this was the equation of the curve. So basically we are taking away the volume that will get generated by the line, and we are taking away the volume that will get generated by the curve, below the curve. So then only we will be left with the area of the, or the volume of the shaded region when it is rotated 360 degree about the x-axis. So now we can simplify it by saying 25 minus 10x plus x square minus 16x to the power minus 2. So when we integrate this, it will become 25x minus, this will become x to the power 1 plus 1 is x square. 10 by 2 will give us 5. plus 2 plus 1 is 3, and this will become 1/3, plus 16x. The reason it's plus because minus 2 plus 1 is minus 1, and 1 by minus 1 is minus 1. So minus minus will become positive. So this will become 16x to the power minus 1. And the limits that we have is 4 and 1. So substituting the value 4 and 1 into the x, we will get 9 pi. This whole value will come down to 9, and 9 times pi is 9 pi. And in decimals, it will be 28.3. Question number 7. The first two terms of an arithmetic progression are 16 and 24. Find the least number of terms of the progression which must be taken for their sum to exceed 20,000. So the first term is 16 and the second term is 24. So a is 16 and a plus d is 24. So with the help of equation 1 and 2, we get that 16 plus d is equals to 24. That means d is equals to 8. So the sum of terms which needs to exceed 20,000. So we can use the formula n by 2 times 2a plus n minus 1 into d, where a is 16 and the common difference is 8. So if we cross multiply, 2 times 20,000 will give us 40,000. So this will become 32 plus 8n minus 8. Then simplifying it further, we get 8n plus 24. Now if we multiply n with 8n will give us 8n square plus 24n. Minus 40,000 is greater than 0. If we simplify this whole equation by dividing all the coefficients by 8, we will get n square plus 3n minus 5,000. It's always better to check whether you can simplify the equation. That saves a lot of effort. So with the help of quadratic formula, we can see that n is equals to minus 3 plus minus root over 3 square minus 4 times 1 times negative 5,000. So simplifying it, we get minus 3 plus minus root over 20,009 over 2. So n will be, from this equation, we get n could be either 69.2 or n could be negative 72.2. But we know that n is considered as the number of term, and n cannot be 0, so n is greater than 0. Not only that, n cannot be a decimal, it has to be an integer. So 69.2 tells us that 69th value will not exceed 20,000. So it must go above 69th term. So that means 70th term is the term at which it exceeds 20,000. In part B, a geometric progression has a first term of 6 and a sum to infinity of 18. A new geometric progression is formed by squaring each of the terms of the original progression. Find the sum to infinity of the new progression. So this is the first geometric progression where first term is 6 and the sum to infinity is 18. We know that sum to infinity is a by 1 minus r. So a by 1 minus r is equals to 18. We also know the value of a, which is 6. So it can be written as 6 over 1 minus r equals to 18. Therefore 1 minus r should be equal to 1/3. So if we cross multiply, 1 minus r can be replaced by 18. So 6 over 18 can be written as 1 over 3. So r should be 1 minus 1/3. So that will give us 2/3. So a is 6 and ar, which is the second term, should be 6 times 2 over 3, because a is 6 and r is 2 over 3. So the first geometric progression has the first term as 6 and the second term as 4. Now for the second geometric progression, it's said in the question that the terms are squared. That means the first term for the second geometric progression should be 6 squared, which is 36. And the second term will be 4 squared, which is 16. So let's find the common ratio. The common ratio is next term divided by the previous term. So the next term is 16 and the previous term is 36. So that will give us 4 over 9. So the sum to infinity should be a by 1 minus r, where a in this second geometric progression is 36 and the common ratio is 4/9. So that will be 64.8. Question number 8 is not in the syllabus at the moment. Question number 9. The equation of the curve is y is equals to 8 root x minus 2x. Find the coordinates of the stationary point of the curve. So y is equals to 8x to the power half minus 2x. So since we are talking about the stationary point, that means we need to find the differentiation for the curve, which is dy by dx. So dy by dx should be half times 8 is 4 and half minus 1 is negative half minus 2. Or we can write it as 4 over root x minus 2. We know that at stationary point dy by dx is equals to 0. So 4 over root x minus 2 is equals to 0. And if we cross multiply root x with 0, but before doing that we must multiply root x with 2 because there is nothing in the denominator. So 4 minus 2 root x is equals to 0. So 2 root x is equals to 4. Or we can say root x is equals to 2. Now squaring both sides will give us x is equals to positive 4. When x is equals to positive 4, y is equals to 8 root 4 minus 2 times 4. Because that was the equation of the curve. So we are trying to find the y coordinate when x equals to 4. So that will give us 8 times 2 minus 8. So 16 minus 8 will give us 8. So the coordinate is 4 and 8. And that is the stationary point of the curve. In part 2, it says find an expression for d square y by dx square and hence or otherwise determine the nature of this stationary point. So dy by dx we found was 4x to the power negative half minus 2. So the second derivative should be minus half times 4 is negative 2 and minus half minus 1 is negative 3 over 2 and this will become 0. So this can be written as minus 2 over x root x because x to the power 3 by 2 when it comes to the denominator we can write it as x root x because the power of x is 1 and the power of this x is half. So 1 plus half is 3 by 2. So you can write it as x root x. So when x is equals to 4, the second derivative should be minus 2 over 4 times root 4. So which is equals to minus 2 over 4 to the 8. Or we can say this is minus 1 over 4. That will give us minus 0.25. Since the second derivative is less than 0, that means it's a maximum point. Part 3, it says find the values of x at which the line y equals to 6 meets the curve. So this is the equation of the curve and this is the line where y equals to 6. So equating these two equations, we get 8 root x minus 2x is equals to 6. So 8 root x minus 2x minus 6 equals to 0. Or we can say minus 2x plus 8 root x minus 6 is equals to 0. Multiplying both sides by negative 1 will give us 2x minus 8 root x plus 6. If we consider a to be root x, then we can say that this is 2a square because when you square root x, you get x. So this should be 2a square minus 8a plus 6 equals to 0. Now again, dividing both sides by 2, we get a square minus 4a plus 3 is equals to 0. Or we can say a square minus 3a minus a plus 3 is equals to 0. We can take a common and this will become a minus 3 minus 1a minus 3 equals 0. So the factors are a minus 1 and a minus 3. So a is 1 and a is positive 3. Or we can say that root x is equals to 1 and root x equals to 3. So in order to find x, we can simply square both sides. That will give us x is equals to 1 and x is equals to 9. So these were the required values of x that we needed to find. In part 4, it says state the set of values of x, set of values of k, for which the line y equals to k does not meet the curve. So whenever they state the term set of values. That means they're talking about an inequality. So let's write 8 root x minus 2x equals to k. So I'm equating the equation of the curve and the equation of this line, y equals to k. So we can say 8 root x minus 2x minus k is equals to 0. Minus 2x plus 8 root x minus k is equals to 0. Multiplying both sides by -1 will give us 2x minus 8 root x plus k is equals to 0. Since they will not meet, the y equals to k does not meet the curve, that means the discriminant should be less than 0. So minus 8 whole square, where a is 2, b is -8, and c is k. So b square minus 4ac will be minus 8 whole square minus 4, a will be 2 and c will be k. So minus 8 whole square is 64, minus this will become 8k less than 0. So minus 8k is less than -64. Multiplying both sides by -1 will cause it to be 8k greater than 64. Since we are multiplying with -1 on both sides, the inequality sign will flip. So 8k is now greater than 64, so k should be greater than 8. Question number 10. The function f is defined by f of x equals to 3 10 half x minus 2. And the limit is minus pi by 2 to pi by 2. Solve the equation f of x plus 4 equals to 0, giving your answer correct to one decimal place. So f of x plus 4 is equals to 0. So that means 3 10 half x minus 2 plus 4 is equals to 0. Or we can say 3 10 a plus 2 equals to 0. I'm considering half x to be a. And we also need to fix the domain first because this is half x and this is x. So for x, the question stated that x lies between minus pi by 2 and positive pi by 2. So for half x, we need to multiply both this value and this value with half, and that will give us negative pi by 4, and this will be positive pi by 4. I'm considering half x to be a. So I can write it as 3 10 a plus 2 is equals to 0. And now we will work with this new limit. So 10a should be negative 2 over 3. Now let's find the basic angle. Alpha is equals to tan inverse of positive 2 over 3. So alpha is equals to 0.588. And you need to make sure that your calculator is in radians because we have pi by 2 as the value of the angle, which is in radians. So since our original angle is negative, that means 10 will be in the negative quadrants, which is the second quadrant and the fourth quadrant. Now we can say that a should be equal to minus 0.588 because first we need to find the negative angles. So if we go clockwise, if the basic angle is 0.588, that means the negative angle when going clockwise will be minus 0.588, and we can't go over here. We can't have any angle in this quadrant because tan is not negative in this quadrant, in the first quadrant. So that is the only value that we can have. And a is half x. So half x is equals to minus 0.588. So x should be equal to, by multiplying 2 with minus 0.588, we get minus 1.176. Or in correct to two decimal places, we will get minus 1.2. In part 2, it says find an expression for f inverse of x and find the domain of f inverse. Now let's say that the equation f of x equals to 3 10 half x minus 2. So let's consider y is equals to f of x. So y will be equals to 3 10 half x minus 2. So 10 half x will be y plus 2 over 3. So half x should be 10 inverse of y plus 2 by 3. That means x should be 2 times 10 inverse of y plus 2 by 3. F inverse of y is equals to x, which means f inverse of y is 2 tan inverse of y plus 2 by 3. Therefore, f inverse of x should be 2 tan inverse of x plus 2 by 3. We know that in order to find the domain of f inverse, we know that domain of f inverse of x is equal to the range of f of x. So our grid for 10 is this. This is the original grid where we have 0 in 0 degrees, 1 in 45 degrees, and infinity in the 90 degree. So when we have 3 getting multiplied, so it will become, all these value will remain the same except this. It will become 3 times 1 is 3, and this will remain 0 because 3 times 0 is 0. So since our limit in the original question was x lies between negative pi by 2 and positive pi by 2, that was the domain, and the range that we get for the domain is -5 and 1. The reason is the equation is 3 10 half x minus 2. So first we multiplied 3 with all these values of the grid, and then if we take away 2 from all these values of the grid, it will become 3 minus 2 is 1, and -3 minus 2 will be -5. That is the new range. So this is the range for f of x. That means our domain of f inverse, which we are required to find, is -5 and 1. In part 3, it says, sketch on the same diagram the graphs of y equals to f of x and y equals to f inverse of x. So f of x, as you can see, that we have the domain over here, minus pi by 2 is over here. That is the domain, which gives us -5, and positive pi by 2 gives us the range of +1 in the y-axis. So therefore, the inverse of the function is a reflection along the line y equals to x. So the x and y coordinate of f of x will switch. So now the domain is 1 for f inverse of x, and the also -5 is the limit of the domain. So the domain lies between -5 and +1 for f inverse of x, and the range becomes positive pi by 2 and negative pi by 2. And that will be all for now. I will see you in the next video.